Hi, I'm doing this video to help you compute probabilities. According to Master Foods, the company that manufactures M&Ms, 12% of M&Ms are brown, 15% are yellow, 12% are red, 23% are blue, 23% are orange, and 15% are green. And they warn us here to round your answers to 3 decimal places. They say compute the probability that a randomly selected peanut M&M is not blue. So if it's not blue, well, may I think about this is the probability of it not being blue is equal to 1 minus the probability that it is like any other color, because not blue is like this. If you add up all the other possibilities it could be and you subtract from 1, then you can get the probability that it's not blue. Hold on a second here. Sorry about that. I was thinking about that wrong. Sorry. What you could do is you could count what is the probability that it is blue and then subtract that from 1, because the probability that it's not blue, which really means the probability that it's green, orange, red, blue, all the other colors, is equal to 1 minus the probability that it is blue. So the probability that it is blue is, where is blue, of 23%. The probability is the same as the proportion that theirs are as well. So we can write this 23% as a decimal. So when you write a percent as a decimal, then you have to drop the percent sign and you move the decimal 2 places to the left. So it's 1 minus 0.023. And that's because that's true for every single thing and every single outcome. It's either not blue or it is blue. So they're the complement of each other. So 7 and 7, right? 0.77. And that's exactly what they get. Okay, for the next one. Compute the probability that a randomly selected M&M is green or brown. So the probability that it's green or brown. Now, there is a general rule and a regular rule for things that are mutually exclusive or things that cannot occur at the same time, that if you're asking the probability of it being green or brown, you just find the probability of it being green and you add it to the probability of it being brown. That is if being brown and being green are 2 disjoint, mutually exclusive events. In other words, you have to ask yourself, can one of these M&Ms be both green and brown at the same time? If that is true, then they're not mutually exclusive. They're not just joint. But here you can't be green and brown at the same time. So this is going to work. They're mutually exclusive, disjoint events. So we can't just find the probability of green, which is 15%. So writing as a decimal is 0.105. And then the probability of being brown, which is 12% of it are brown. So it's 0.12. And I just add those together And I just get 0.27. And there we go. That's our probability for that. Let's just double check it. All right, now yeah, that's correct. Going on to the next one. Compute the probability that two randomly selected M&Ms are both red. So this is like two events happening in the first event and the second event occurring. So the probability the first M&M chosen is red. And I believe they're thinking we're replacing it. We're replacing the M&M in the jar. I believe that I think they would tell you if it was otherwise, if it was not being replaced. Because that would be harder to calculate. It'd be even harder for us to calculate without replacement here. But the probability, so what we're really looking for here is the probability of red and a second one being pulled out, red. So this formula has you, whenever you want two events to occur, you multiply the probability of it being red, the first one being red, times the probability of the second one being red. That is, and this formula will work if the two events are independent, meaning that if the first event occurs, it doesn't affect the probability of the second event happening. And if we're replacing the M&Ms, then they're independent events. And it sounds like perhaps we are randomly choosing from a very, very large amount of M&Ms. So if that's the case, then we can just assume that they're independent events as well. So the probability of red is 12% are red, so 0.12, and then times the probability of the second one being red is 0.012. So you get 12 times 12 is 144, and then it's going to be over 4 decimal places, so 0.0144. All right, and the last one, if you randomly select 6 M&Ms, compute the probability that none of them are red. So we know the probability of one of them, of it being red, probability of it being red is, where's the red again? It's 0.12. But the probability of picking 6 and none of them being red. So first we have to find the probability of it not being red, of just one of them not being red. The probability of it being not red is 1 minus the probability that it is red. That's because these are complement events. Either that's true for every single thing in our sample space, and the different things in our sample space are the different color M&Ms. For all the different color M&Ms, yellow, brown, blue, orange, when we ask, is it red or not red, all of the M&Ms fit into one of those categories. So it makes ones that are red and the ones that are not red, if you put all of those together, they make all of the total sample space. And there's all the total possible things that happen. And when we pick M&Ms out of the jar. So they're complements. So I could just, to find not red, I just do 1 minus the opposite of that, red. So red was 0.12. So the probability of not red is 0.88. Okay? All right, and then the probability, now that there was a probability that we pick six M&Ms, and they're all not red. None of them are red. So it would be the probability of them not being red is 0.888. So if we just have to multiply that 6 times, or if we write it to the 6th power. So to multiply 0.88 times by itself 6 times. Once for the first M&M, once for the second M&M, third M&M, fourth M&M, and so on. So what do we get there? I probably want to have my bigger calculator here. Where is... Okay, so I just put 0, you don't have to put 0, but 0.88, and then I can raise it to any power that I want to, and we can do, there's an x to the y on the calculator normally. It looks like x to the y. I don't see it at this moment. We can also use this little caret to the 6th power, and then it gives us, it's 0.4644, and there's our answer. Okay, and then the last one. If you randomly select 6 M&Ms, compute the probability that at least one of them is red. So they're either none of these 6 are red, right? Either none of those 6 M&Ms are red, or at least one of them is red. Every outcome, if I pick 6 M&Ms, every different outcome of the different color combinations, like let's just say the first combination might be, okay, I picked 6 M&Ms, so the first combination might be, yellow, red, blue, green, brown, 5, and orange, right? That could be my first combination. And then the second combination could be all orange. Like the third combination could be all orange and one blue, but every combination that we think of is either going to fall in the category of all being not red, okay, so, or at least one red, right? If we looked at all of these different, if we wrote out all the different combinations of all the possible different color combinations that we could pick, that's our sample space, the total outcomes. All of those outcomes could be split into 2 mutually exclusive groups. It means groups that don't have overlap. And all of them would be either in no red or at least one red. So these are the complement of each other. So if I want to find the probability of at least one red, of the 6 marbles, I just have to do 1, my probability that none of them are red. And we already got the probability of the 6 of them being not red in the previous section. That was I didn't write it down, but it's like 0.4646. That was I have to look at the answer again. 0.46440. We'll try to keep it. And actually, I would keep that in my calculator. I would not write that out. I'm just writing it out so we kind of have a memory of that answer. But I would leave it in my calculator so that I don't have to truncate anything. I would take this now and go 1. Oh, oops. I need to get out. First, I need to get out of that. I'm going to delete 1. Okay. I'm going to get out of this. See, I'm currently in I'm in this number up there, which I don't want to be. And I think it's because I didn't press enter. Okay. Now I do 1 minus, and then if you do the minus sign here, then it just takes the previous answer and so it input every single decimal place here down here so that I don't have to re-enter it. So 1 minus the answer and enter. So that's 0.5355. So the probability that at least one of it is red is 0.5355. I'm just going to write 4644, but you saw me, I kept all the decimals in there. And then I'll truncate this because it's my final answer. And they wanted it accurate to 3 decimal places. And I haven't been like worried about that when I was doing this problem, but you do want to be worried about that when you are plugging in. So I would go 1, 2, 3, that's 3 decimal places. So I'm going to look to the one to the right, and that's 5 or greater. So I add here, so it's 0.536. And that's it. That's this total problem. See how valuable that the probability of at least one red is equal to 1 minus probability of it not being red. All right. Have a great day, everyone. Bye.